In this video, I'm going to discuss the possible solutions, the thinking through the possible solutions for question number 17 of row 3 homework on your own. So what we have is a water wheel, and what we really want to look at is that in the diagram, the water wheel has a 30-foot diameter, and it's positioned at the coordinate system so that the center of the wheel is at the origin. Now the origin is another way of saying it's at the order pair 0, 0. So we're going to locate that at 0, 0. And the water wheel reaches 3 feet below the water level, so when we hit down to B, it's 3 feet below the water. As the water wheel rotates, it takes 12 seconds for point A to turn on the circumference of the circle and back to starting position. So in other words, it takes 12 seconds to do one complete rotation around the circle and back to where it started. The first question asks, what are the coordinates of all of the points that are labeled? So they told us that it was centered at the origin, so the order pair is 0, 0. It said that the diameter of this wheel was 30, so if we get out to A, we go 15, half of that 30 for the diameter, so 15 units, so this is the order pair 15, 0. If we go down to B, we go down, straight down 15 units, so that's the order pair 0, negative 15. They told us that it hits 3 feet in the water, so the water wheel reaches 3 feet below the water, so that means point C has to be 3 feet shorter than that. So if I put the coordinates for C, it's going to be 0, negative 12. And then we want D and E. We're going to have to do a little bit of work on D and E. So to do that, I'm going to come over here and use this other diagram to try to simplify where it's going to go. I've got to send this back for a moment. Order, send back. Okay. So to do that, to find the coordinates of E and D, what I'm going to do is make a right triangle here. The right triangle I'm going to create is going to be formed by the red and the blue line. So the things I know about this triangle so far is that if I go from O to C, it has to have a length of 12. From our coordinates, we knew that we went down 12 units, so it has a length of 12. And I also know that this blue line has to be the length of the radius, so that is 15. We can find the length of the reds then by using our Pythagorean theorem. Since we have a horizontal and vertical line, it makes a right angle. So our 15 squared, which is the hypotenuse, has to equal the other two legs squared, 12 squared plus whatever we want to call this, x squared. So that means 15 squared is 225, equals 144 plus x squared. And then we have to take 225 minus 144. Rather than make a mistake, I'm going to calculate that quick. Quit. Clear those. 225 minus 144. Enter. That's 81. Okay, so that means x squared is equal to 81. So that makes a quick work of that one. If x squared is equal to 81, then x has to equal 9. So that means we're 9 units over. So now I can finish this rest of the problem that we're working on. The order pair for E is the order pair 9, negative 12. We went 9 units to the right, we went down 12 units. So this length from here to here is now the same. Well, I'm just going to point out it is exactly the same as what we had on the other 12 there, so that's 12. So all in all, we got our order pairs for everything except D, and D is symmetrical to E, so this is the order pair. The only difference is we're going to go negative 9, negative 12. So we just finished part A. What are the coordinates of the other visible points? In part B, at its current position, how far is point A from the surface of the water? Well, if we look at point A has to be exactly 12 units above the water. Vertical distance to the water is 12, so it is 12 feet above the water. Okay, letter C. If the wheel rotates counterclockwise, through what angle does A rotate to first reach the water at D? So interpreting that means we got to start at point A, we got to go counterclockwise, and we want to figure out what is the angle of measure that it takes to finally get to the water for the first time at point D. Okay, so that's the angle we're going to calculate. Some things that I'm looking at right away is if I keep going around this circle, I just went 90 degrees here, then if I go another quarter of a turn, we've got 180 degrees already wrapped up. Then I want to know what the rest of this is from here to here. So really the calculation we're going to want is what is the angle that if I just sectioned off in green, I'm going to highlight in blue. To do that, what I'm going to do is going to drag this point over here, I'm going to use that side of 15. I'm going to use this side of 9. And let me clear some of this off. We still have a radius which is 15 feet long. We still know we went 9 units to the right. We want to be able to figure out what this angle is right here. So in order to figure out what that angle is there, I'm going to use this reference triangle in here and find that angle. And then I know that in any one of these quarter turns there's 90 degrees. So in this whole thing there's 90 degrees. So I can subtract my answer from 90 to figure out what the angle in blue is. So I'm going to start those calculations. What I'd really like to do is I'd like to be able to find this angle. I'm just going to call it angle A. To find angle A, I know the side that is opposite. I know the hypotenuse. Opposite and hypotenuse, you say to use the sine. So I'm going to use the sine of the angle A is equal to 9 over 15. To find angle A, we do the inverse sine to solve the equation. So 9/15. So now I'm going to calculate the inverse sine of 9/15. Make sure I'm in degree mode. So we're going to do the inverse sine of 9/15. And it'll tell us what that angle is. And it says that angle is approximately 36.7 degrees. So angle A is 36.7 degrees. So in this little piece right here, 36.7 degrees, what is left out of this 90 degree angle is what I wanted, this blue part. So now I'm going to take 90 minus the 36.7 degrees. So quick calculation on that. So 90 minus 36.7. I don't know why I put 36.7 now I'm looking at. 36.9 is what I should have been writing down. So I'm going to go back and correct those. 36.9 degrees. 36.9 degrees, and then this one over here was 36.9 degrees. Now I'm going to actually do that calculation. Minus 36.9. Hit enter. That remaining angle is 53 point, and I lost it again, 1 degrees. So our point A rotated 90 plus another 90 or 180 plus another 53.1. So now I'm going to take 180 plus 53.1. So we're going to take 180 plus 53.1, and our approximate angle of rotation is 233.1 degrees. So what we just answered was this part of letter C. That was 233.1 degrees. I don't know if you want to do it a different way. Here's a different way of thinking of it. If you were to rotate around from A all the way over to B, that is 3/4 way around the circle, or 270 degrees, but you would have to back off of that, come back this angle, so we would subtract our 36.9 degrees from 270. So another way would do the 270 degrees minus 36.9 degrees, and you'll still get the same angle of rotation, whichever one seems to be easier for you to manage. Now the second part of that question says, how many seconds will it take for A to reach the water? Well, what we do know is that it takes 12 seconds for it to complete one full rotation. So again, I'm going to re-emphasize that by just drawing. If I go around one complete rotation, one revolution, a rotation equals 12 seconds. Now because we just said we're going to go 233.1 degrees, we want to convert one revolution into degrees. So one revolution is 360 degrees in one revolution. So I'm going to use the power of ratio proportion. If one rotation, or one 360 degree rotation, is equal to 12 seconds, then if I want to travel 233.1 degrees, how many seconds will it take? So if one rotation, which is 360 degrees, takes 12 seconds, then 233.1 degrees should equal how many seconds? So we're going to solve proportion. Our typical method on this is a cross multiply. So we're going to take 360 degrees times x. We're going to take 12 times 233.1. And then to get x by itself, I'm going to have to divide by 360. And this will tell us how many seconds it should take. Okay, so we're going to do the calculations at this point. We're going to take our 12 times our 233.1. Okay, let's try to get a 12 times 233.1 degrees. I'm going to hit enter, and then I want to take that answer and divide it by 360 equals, says it should take about 7.7 seconds. Okay, so now we just answered letter C. Part D. The surface of the water forms a chord DE. What is the measure of arc DE, and what is the length of the chord DE? So we've got two things to answer here. One of the things we want to do is we want to find the measure of arc DE. Now arc DE is the portion of the circle that is cut off by not only this radius, I'm going to copy that, and I'm going to paste it down here, but also from O to E. So what we want to do in this problem is find the intercepted arc cut off by the angle formed at the center. Well, we just got done calculating that this angle sitting in here was 30, I gotta remember, it was 30, okay, I don't remember, did I have it on the calculator? Didn't. Give me a second, I'm gonna go find out what that value was since I erased it. Okay, I counted it, was 36.9 degrees. We calculated that earlier, 36.9 degrees for this angle sitting in here. The identical angle is sitting right over here because these two triangles are going to be congruent by hypotenuse leg. They're both right triangles, they both share the radius, and these are both 9, so they're congruent triangles. So because they're congruent, and this angle sitting in here is 36.9, we're going to take it times 2 and figure out what the entire central angle is, and this intercepted arc, DE, is equal to its central angle. So the calculation we'll perform is simply 36.9 times 2, and we got a 73.8 degree central angle. So that central angle is 78.3 degrees. The intercepted arc is identical, 73.8 degrees as well. So the central angle that they're asking for and the arc, 73.8 degrees. The next thing we're going to do is we're going to find the length of the chord. The length of the chord that's created by the water can be represented by this dashed line. We have to work with right triangles, so as we have done before, we're going to go from the center to the midpoint of this chord. Center to midpoint always creates a right angle, gives us our right triangle. We already know the information about this. This is a 15, this is a 9. So if that was a 9, so the 9 and a 9 has to be 18. So the length of that chord is 18. And finally, it asks us, what is the measure of the inscribed angle DAE? So I have to be careful to find the actual measurement of D to A to E. So I'm going to highlight that with the blue lines. We've got to go from D to A to E. Now, because that's an inscribed angle, inscribed angles are always equal to half of this intercepted arc. And the arc that it's intercepting is arc DE. And arc DE, we just calculated that to be a 73.8 degree arc. So in order to get the measure of angle A, we simply take half of that 73.8 degree angle. And that means we're going to get back to our angle that we had here, which was 36.9 degrees. So that's an explanation on what you can do and how to solve question number 7.